In this video, we're going to show how we use tan's angle sum and difference identity by doing some examples. So with our first example, we have tan of A is equal to root 3 over 3, and tan of B is 2 root 3 over 3, and we need to find tan of A plus B. And so we're going to start by writing in our angle sum identity for tangent. So we're going to have tan of A plus B. And this is equal to tan of A, which is given as root 3 over 3, plus, because we're using the top operator in this formula to use the sum identity, so we're plus tan of B, and that is given as 2 root 3 over 3. And we're dividing by 1, and we're using the top operator again because we're using the sum identity, 1 take tan of A times tan of B. Now tan of A is given as root 3 over 3, and tan of B is 2 root 3 over 3. Now we're at the point where we can simplify, and the best way to do this is by considering the top and bottom of the fraction separately. And so let's write in the top of our fraction here. And so we have root 3 on 3 plus 2 root 3 on 3, and this is equal to, well, we have 2 of root 3 on 3, and we have 1 root 3 on 3, and we're adding them together, so we're going to end up having 3 root 3 on 3. And notice here that our 3's cancel out, and we're just left with root 3. So the top of our fraction is just equal to root 3 when simplified down. And now we can consider the bottom of our fraction. And the bottom of our fraction is given as 1 subtract root 3 on 3 times 2 root 3 on 3. And now we can multiply out these fractions, so we end up with 1 subtract 2 times root 3 times root 3, and that's root 3 squared, and the square roots cancel out, so we're just left with 2 times 3 on the top of our fraction. And on the bottom we have 3 times 3, which is just 9. And so this simplifies into 1 take 2 times 3, which is 6, divided by 9. And 6 divided by 9 can simplify into 2 over 3. And so we have 1 take 2 over 3. And let's replace this 1 with 3 over 3, so we have the same denominators. And we have 3 over 3 take 2 over 3, which is going to equal 1 over 3. And so the bottom of our fraction is going to be equal to a third. And now we can finally find our result for tan of A plus B. So we have tan of A plus B is equal to root 3, the top of our fraction, divided by 1 over 3, which was the bottom of our fraction simplified. And now we can change this into a times if we flip the fraction of 1/3 to 3 over 1. And now we get our value of tan of A plus B as 3 root 3. And so that concludes this example, and let's move on to another. For our next example, we're required to show that the exact value of tan of 75 degrees is equal to root 3 plus 2. Now, whenever we have these types of problems, we need to find a combination of the common angles that we do know that make our angle that we're required to find. And this angle is 75 degrees. And in this case, 30 degrees plus 45 degrees will give us 75 degrees. So let's change our expression for tan of 75 degrees and make it equal to tan of 30 degrees plus 45 degrees. And now we can use the angle sum identity for tangent to find our exact value. And so using our angle sum identity, we'll have tan of our first angle, which is going to be tan of 30 degrees. And we're going to be using the top operator as we're using the sum identity, and we're going to add tan of our second angle, which is tan of 45 degrees. And now we're dividing by 1, and we're using the top operator again, so subtract tan of A times tan of b, which is going to be tan of 30 degrees, times tan of our second angle, which is 45 degrees. So now we have changed our problem in terms of angles that we know the exact values of, and now we can use the Masterly table to evaluate and then simplify. So when considering tan on the Masterly table, remember we ignore the divide 2 sign and we just do sine divided by cosine. So starting with tan of 30, we go along the 30 degree column and we have sine, which is going to be root 1 divided by cosine, which is root 3. So root 1 is just 1 divided by root 3, and this is our value for tan of 30 degrees. And we're going to rationalize the denominator by timesing and dividing by root 3. And we get root 3 times 1, which is root 3. And we're dividing by root 3 times root 3, which is root 3 squared. And the square roots cancel out, so we're just left with 3. So let's write root 3 over 3 as our solution for tan of 30. So we get root 3 on 3. And now we're going to add tan of 45 degrees. So again, going along the 45 degree column, we're going to have the square root of 2, divided by the square root of 2. So that's going to give us 1. So we get tan of 45 is equal to root 2 on root 2, which equals 1. And now we're dividing by the bottom of our fraction, which is going to be 1 subtract tan of 30, which we found to be root 3 on 3, times tan of 45, which is just multiplied by 1. And now to simplify, we're going to consider the top and bottom of our fraction separately. So considering the top first, we have root 3 on 3 plus 1. And we're going to change the 1 to 3 over 3. And so we got root 3 on 3 plus 1, which is the same as 3 divided by 3. And now we have the same denominator, and so we can have root 3 plus 3 over 3 as our solution for the top of our fraction. So we get 3 plus root 3 divided by 3. And so the top of our fraction simplifies into this expression here. And now considering the bottom of our fraction, we have 1 take root 3 on 3 times 1, which is just going to be 1 take root 3 on 3. And we're going to change the 1 to 3 on 3, take root 3 on 3. And this equals 3 take the square root of 3 divided by 3. And so the bottom of our fraction simplifies into this expression here. And now let's rub out this right-hand side to leave some room to finish off this problem. And so let's just write in our fraction again. So now we have tan of 75 degrees is now equal to the top of our fraction, which was 3 plus root 3 divided by 3, divided by the bottom of our fraction, which is 3 take root 3 divided by 3. And now we can flip the fraction and make it into a times. So let's do that. So we have a times here, and the top of our fraction will become the 3, and the bottom will change into the 3 subtract root 3. And notice here that our 3's will cancel out. And so we're left with tan of 75 degrees as 3 plus root 3 divided by 3 take root 3. Now notice that we have a square root sign on the bottom of our fraction, and so our expression is not in the simplest form it can be. And so the way we're going to rationalize the denominator is by timesing and dividing by 3 plus root 3. So we're going to have 3 plus the square root of 3 divided by 3 plus the square root of 3. And the reason why we're going to do this is because when we multiply this value by this value here, the square roots will cancel out. And so let's show how this is the case. So we're going to rewrite our expression. We're going to have 3 plus the square root of 3 times 3 plus the square root of 3. And we're dividing this by 3 take the square root of 3 by 3 plus the square root of 3. And so let's expand each part of the fraction separately. And so to the side, let's do the top of our fraction first. I'm going to have 3 times 3, which is 9. And this is using our crab claw method of expansion. We're going to have 3 times root 3. So we're going to have plus 3 root 3. And then we're going to have 3 root 3 times 3, which is going to be another 3 root 3 that we're adding on. So this 3 is going to change into a 6. And then we're going to have root 3 times root 3, which is going to be root 3 squared, and the square roots cancel out, so we're left with plus 3. And notice here we're going to have 9 plus 3, which is going to be 12, plus 6 root 3. So the top of our fraction expands into this expression here. And let's see what the bottom of our fraction expands into. So we have 3 times 3, which is 9. And then we're going to have 3 times root 3, which is going to be plus 3 root 3. And then we're going to have negative root 3 times 3, which is going to be negative 3 root 3. And then we're going to have negative root 3 times root 3, which is going to be negative root 3 squared, and the square roots cancel out, so we're left with negative 3. And so notice here that we have a square root, 3 root 3 take 3 root 3. So these cancel out, and we're left with 9 take 3, which is going to equal 6. And so let's add these to our fraction and then simplify further. And so we've shown that the top of our fraction simplified into 12 plus 6 root 3, and the bottom of our fraction has been rationalized, and it is a whole number with the value 6. And now to make our final simplifications, we can see that we can factor out a 6 on the top of our fraction. So we have 6, and in the brackets we're going to have 2, as 6 times 2 is 12, and then we're going to have plus root 3. And notice if we expanded this out, we'll have 6 times 2, which is 12, plus 6 times root 3, which is going to give us our 6 root 3 back. And now we're dividing this all by 6, and notice that our 6 cancel out, and we're left with the expression that we're meant to show in our problem, which is the square root of 3 plus 2. And so that finishes this example, and let's move on to one final example. For our last example, we're required to solve the following expression for angles between 0 and pi radians. Now the best way to approach this question is by first just considering the left-hand side. And we're going to try to simplify this and then see what we're going to do from there. So rewriting the left-hand side of our expression, we're going to have tan of 2x, take tan of x, divided by 1 plus tan 2x times tan of x. Now you can see that this awfully looks like our angle, one of our angle sum or difference identities for tangent. And so what we're going to do is we're going to make a dummy variable, and we're going to let a equal 2x, one of these angles, and b equal x, our other angle. And we're going to make this substitution in, and so we're going to have tan of a take tan of b, which is x in this case, divided by 1 plus tan of 2x, which was a, times tan of x, which is going to give us tan of b. And now if we match our expressions here, we can see that we have the angle difference identity for tangent, as we have a negative up the top and a positive at the bottom. And so we can change this expression to simplify into tan of a take b. And now rewriting our values for a and b, this is tan of 2x, which was a, subtract b, which was x, and finally we get tan of 2x subtract x, which is just going to give us tan of x. So in fact, our left-hand side of our expression simplifies into tan of x. Now let's rub this out to leave some room, and we're going to finish off solving our expression. So now let's rewrite our expression, and we show that the left-hand side was just equal to tan of x. So let's just write tan of x in, and this is equal to 1 divided by 2 cos of x. Now, to simplify this further, let's bring the cos to the other side of the equation, and we're going to end up with tan of x times cos of x is equal to 1 divided by 2. And now we can replace tan with sine divided by cosine, and so we're going to have sine of x divided by cos of x times cos of x is equal to 1 over 2. And so notice here that our cos's cancel out, and we're just left with the expression to solve of sine x is equal to a half. So now let's rub this out and leave some room to draw our unit circle and solve for our solutions of x. So we have the unit circle drawn and we're solving for sine of x equals to a half between 0 and pi radians. So first we're going to be writing in our domain. So our domain is between 0 and pi radians. So we're going to start on the positive x-axis at 0 radians and go halfway around the unit circle to get to our angle of pi radians, which is this angle right here. And because we're dealing with sine, we're going to be reading off the y-axis and we're finding sine of x equals to a half. So let's find a half on the y-axis, which is going to be about halfway between our origin and our circumference of the unit circle. So about this value here. And if we draw our dotted lines out, we can find rough estimates for our angle. So let's write in these angles. So you can see here that we're solving for two angles, one in the first and one in the second quadrant. And now we can use the Masterly table to find our angle in the first quadrant. So this solution is going to be when sine of x is equal to a half, well, we go along the sine row, and we're looking for a half, and we get the square root of 1 divided by 2, which is this column at pi on 6 radians. So the angle at our first quadrant is going to be pi on 6 radians, this angle here. And now to reflect this into our second quadrant, we can go to 6 pi on 6 radians, which is the same as pi radians. And if we subtract pi on 6 radians, we get to this angle, which is going to be 6 pi on 6, subtract pi on 6. This is going to be 5 pi on 6 radians. So our angle here will be 5 pi on 6 radians. So our two solutions for x that satisfy the expression above between 0 and pi radians are pi on 6 and 5 pi on 6 radians. And so that's going to conclude this video, and in the next video we're going to do some review questions that cover the concepts throughout the whole playlist.